People across the ages have always been drawn to the question, are we alone or is there life on other planets? From modern days media, we all have an idea about how an alien life looks like. Some even think that this is true. Others think we are the only one who are alive in the universe. But how can we actually figure out? Well, for planets in our own solar system, we can just send satellites and rovers. But for extrasolar planets, we have to rely on other methods of observation. From an unimaginable large number of planets out there, on which one should we focus? What are the best candidates for the origin and evolution of life as we know it? One of the main requirements is the existence of liquid water. And water is only liquid within a certain temperature range. When it's too hot, it will vaporize, and when it's too cold, it will freeze. And only liquid water in a certain temperature range allow for habitable conditions. I learned that it is a combination of different processes which keeps the Earth habitable in its long term. We have volcanic outgassing of CO2 from the mantle into the atmosphere. We have weathering processes, erosion and subduction of sediments, by which CO2 is recycled back into the mantle. Mantle convection leads to a strong cooling of the core, which in turn helps to maintain the magnetic field. And the magnetic field helps to protect the atmosphere. And we can describe all these different processes by mathematical equations and put it into a computer model. All these processes help to keep the planet habitable in the long term. And when you look at our neighboring planets, Mars and Venus, we see that it could have gone dramatically differently. The ice-cold Mars or the blazing hot Venus were both habitable at some point in their history. What determines whether a planet can remain habitable in the long term? Well, we only have one example where it worked out pretty well. It is our own planet Earth, with just the right distance from the Sun and just the right amount of greenhouse gases in the atmosphere. For these extrasolar planets, the problem is that we can't actually go there and measure the surface temperature or the availability of liquid water. They're just too far away. So how can we still know if these planets are habitable or not? Although we cannot directly observe most of the exoplanets with current telescopes, we can still derive some information about the planet by looking at their host star. For example, when a planet moves in front of the star changes its brightness, which gives us an idea about the size of the planet and also about the distance to the star. Or movements of the star caused by the gravity of the planet tells us the mass of the planet. And from the size of the mass, we have an idea about the mean density of the planet, which also gives us an idea about its composition. And we can use all of these parameters and put it into our model to see how the planet would evolve if you, for instance, change the size of the planet, the mass, or the distance to the star. And there are so many different planets out there to actually make these measurements. And by running these models, we can reduce the amount of planets we should be looking at when we search for extraterrestrial life. We can do this because we have a very good understanding of how processes in the Earth work. So all in all, the Earth is a good example of a habitable planet. And the only one so far. But that doesn't mean that other habitable planets are similar to the Earth. They could have different sizes, masses, or different distance to their host star. But still they will follow the same mathematical equations. The better we understand the processes which drive the Earth's evolution, the better we understand the evolution of extrasolar planets, and the better will be our chances of finding extraterrestrial life.